And so through these efforts, we want to go through the process of trying different methods to address everything from the staining to mortar failure to all of the issues that we're dealing with, so that we can shore up the building in the best possible way. Over time, we've encountered some repairs we've found in the past have not been done to the manner and the quality that we would expect.
Buildings like this are very, very significant. And that means that the work that we're doing is extremely important to us, and we need to make sure that we have answers of what we see in the field in order to develop scopes of work for the state of Oklahoma. We start a project usually by looking at historic documents that exist in the file, see how the original design was planned. Then we compare it to actually how the building was constructed, because oftentimes the historic documentation doesn't reflect what's actually out in the field. And in fact, that's the case with the historic windows that we have here at the Oklahoma Capitol.
We have to come in and literally analyze every window type, draw up the details, draw the complex details of how things are put together in the field. It's a kit of parts. As Vance mentioned, one of the elements we're finding deterioration is in the sill, and you can see it down in this location. This would be the window sill, and this is actually a piece of that window sill. And you can start seeing the deterioration that has occurred over the last 100 years. This is an example of what would be the bottom sash piece, which is actually this piece right here. This is a profile taken off of another window, and from the outside it looks pretty nice, but as soon as you start looking at the inside surface of that channel, you start picking up the loss of material. And in this case, where the window is still intact, we were able to start kind of doing some scraping in that joint, and you can actually pull out that rust, deterioration, dirt, grime that's built up over the last 100 years. So this is an example of a piece that was actually took off a sash. Some of the other locations where we're seeing some potential deterioration and penetration or breach of the system is this continuous joint around the perimeter. We have carved out one of those joints to kind of get a feel for what's back there. In some cases that joint has completely failed, so we've got another opportunity for moisture and water penetration.
What we're in right now is really part one of the cleaning trials, where we're trying a number of different techniques to try to find the best cleaning solution that is the gentlest for the building, as well as effective so that it's effective from a cost standpoint. Today what we're doing is chemical cleaning trials, and what we're doing with the chemical cleaning is isolating different types of stains on the building. WJE's initial investigation identified several different types of soiling on the building that needs to be addressed. What you're seeing right here is the trial area for the biological. So we're trying a number of different chemical cleaning methods, so that's different chemicals at different dilution rates and dwell times to try to find something that effectively works on the biological here on the building. Yeah, one of the reasons that the mortar joints are of particular interest on this building though is a bond line failure, which you can see right here in this crack, right where the mortar joint meets the stone unit. That bond line failure is not good. The mortar that was used previously was been identified as a type S through testing, which is also a very hard mortar. It tends to do the opposite of what Vance just described, in that it makes the breathing happen more through the stone than through the joint, which is not how we want it to behave. So we are looking at doing a full repoint, and we're doing some test raking to find out what the conditions are and to find out what's contributing to the bond line failure. And in some locations we're finding very little mortar in the joint, which means there's very little material there to resist any kind of movement. So we have areas where we have some mortar, which is pretty good, and then we have some areas like this one I'll bet may not have much in it, just because it's cracked on two sides.
And of course, because the mortar joint is the sacrificial element of the building envelope through time, when it was done originally, it would typically last 30 to 40 years. As repairs are then made to the building through time, if those repairs are done correctly, they should also be lasting that 30 to 40 year time period. If done incorrectly, all of a sudden you'll find that the life is very, very short on that repair work. And that's what we're finding, is some of the previous repair work, certainly it wasn't done to a higher level of standard.